This conference will now be recorded.
Okay, good morning. Welcome back to Casual Conversations with the HB Architectural Team. It is Wednesday, May 27th, and we're here to talk about flashings, drip edges, peel and stick membranes through wall materials. So I'm going to start things off with a discussion about drip edge as part of the flashing membrane, because I had some experience re-roofing a shed this weekend, which is kind of hard work. I wouldn't recommend doing it for the faint of heart in the warm weather. I was recently watching a video on YouTube by This Old House on the importance of a drip edge for a roof. So I did wanted to share a screen on the concept of a drip edge as part of through wall flashings and what it really is meant to do. And the drip edge is really, really important because what it does is it stops water from clinging to a building. It gives a break. And what it actually does is it uses the effect tension that is inherent in water droplets. And by that, what I'm talking about is water has a tendency to cling to surfaces. It develops a very strong surface tension and affinity to a surface. And in doing so, when it runs down a building, when it has the opportunity to cling to a wall or a facade or return to an eave and get wet in those areas, it can lead to deterioration. So it gets wet, brick can freeze thaw, wood can rot. So it's always in our best interest to try and get that water off of the building and shed it in some way, shape, or form. So this diagram is from RDH Building Science, who we talk about a lot. And one of their people did a test on various types of drip edges and how well they do in terms of creating that break. So the point here is that each drip edge does a different job of being able to do that and break the surface tension of the water droplet, getting it off the building. So with that, I'm going to stop sharing my screen, and I'll pass the next topic of conversation on to Jason.
All right, thanks, Mark. I just wanted to talk. Best practice is using a good termination bar. Depending on your backup materials, kind of gonna configure your spacing of your fasteners. Questions we get brought up a lot is, what's recommended and what's a good practice or fastener to be used. We stress the importance of choosing a fastener that's going to have like a neoprene seal on a washer, where we are penetrating the back of material right there at that turn bar of the fastener. We want to make sure we get sealability right there. So in a steel stud scenario, you're going to use a tech screw with a neoprene washer. If you're going into a concrete or a CMU backup, you're going to want to use something similar like a concrete screw or a Tapcon screw with that neoprene washer. And if the washer is not available, common and best practice is putting a continuous bead of tooled sealant at the top of that turn bar. So at that point, you're just going to also tool and put a bead around each fastener just to give you that seal. I mean, even if you're using a washer, there's no sense in your excess material that you tool away. You might as well tool around that just to ensure that seal and give that good slope and shingle effect for drainage.
And one more thing, if you don't mind if I add off that, Jason, is that the termination bar must go at the top of the flashing. There's been instances where they put it, when I say at the top of the flashing, the termination bar basically has to seal and mechanically adhere, over the top of the flashing. So, in instances, you'll see termination bars being put, slightly below the top of the flashing. And what that allows, in regards to, we'll just say peel and sticks, when those air cavities get really, really hot, those exposed edges will essentially dog ear over, creating, avenues of moisture getting in and behind your flashing, which kind of, neglects the whole purpose of putting that termination bar up there.
Good point.
Do you want to, while you're talking about kind of best practice, do you want to go into end dams and preformed corners before we go into some compatibility things?
Yeah, we can do that. I'll talk just a little bit. So, end dams are a good practice to put at the end of your loose lintels, at the end of walls, corners, pre-manufactured corners, whether it be inside or outside corners. These are generally made out of stainless steel soldered together. And from the install side, you occasionally get a little bit of pushback that they want to just use the flashing that they're using and hand bend and manipulate those on site because of the fear of the cost. But I think what's the misconception here is they're not that expensive. They are a supreme quality product. And the money that you spend on that, you're saving in the labor and the time of manipulating that and adding tooling, adding sealant in spots. And they're going to outlast and outlive a manipulated piece of a peel and stick any day of the week. It's going to eliminate waste, simplify the install. So not only are they best practice, but they really help on the labor side. And I've just seen that personally in the field. So.
Yeah, exactly. One of the biggest things I think we run into today is there's just so many different types of flashing materials out there that people can use. And it's kind of tricky to know which one we should be working with. And I think the biggest thing for us to keep in mind right now is compatibility, especially of, like, is your flashing going to ruin the air barrier below it? Is it going to stick to what's below it? Are those primers going to get in the way? What are all these components that we're putting into this wall assembly? And how do we start looking at them as like working together as a system instead of just individual parts and pieces that need to go back there? And so we have made a change in our product offerings where any of our asphalt-based flashings we have removed from our inventory for a couple of reasons. One, they're just really not compatible with a lot of things. And if they are compatible, they have a tendency to leave that flashing drool. You guys have seen that black coming out of the joints, right? That's just like your asphalt is melting because the temps that go into your wall can reach really high temps that can melt that. It's not the aesthetic anybody is going for. But then the real big part of this is, we're all moving towards trying to eliminate the carbon emissions. We're all moving towards wanting to make sustainable products. And so our contribution to that is that there are more environmentally friendly options for flashings today than the asphalt based. And I know we still see them often in specifications. And so as you're looking at these specifications, we really want you to say, okay, let's eliminate this asphalt and let's start moving towards some different products. One of the ones that we love that gives us an affordable flashing. I know we think stainless steel is not going to be affordable, but because it's so thin, it really can be affordable, is these flexible stainless that still have the option of having the peel and stick for ease of installation, but are going to give you really high puncture resistance, really long durability. They're going to be compatible with everything. They're really, when we're thinking about how do we help your building perform and have the flashing last the life of your building, we really love this idea of the flexible stainless. So does anybody have any other comments on that we want to make?
Yeah, it's in terms of the Mighty Flash, the flexible stainless flashing, or we even offer you're starting to see flexible copper flashings come out as well. To keep you from having to go with the preformed metal that never arrives to the job site in its desired shape and size. Just through transit, it gets damaged, but you can still, it's kind of the best of both worlds. You're able to bend it and form it on site. It comes in a roll. You don't have to worry about an 8-foot skid getting damaged on the way. But at the same time, it's still rugged enough or rigid enough to your typical job site tears and just break down over time as the wall's going up. You're still getting some of those same properties as if you were doing the preformed, pre-bent, just without the headache.
And one other thing in regards to pricing, Copper, you go to, budget your project out, you assume the cost for copper at a certain time. Well, the thing with copper is that it fluctuates in price quite significantly. In 6 months, you budget out this flashing for your project, and then you get to, the bidding stage and you're awarded and you go to purchase it. It can fluctuate up to 30 cents, in that 6-month period, and now you're out of budget. Whereas the stainless steel, if you account for it early, it's going to fluctuate maybe 3 cents in that time span. So that's another important thing to consider.
Mark, what did you have to add?
I was gonna say I wanted to talk about my old shed again because, I was using a peel and stick membrane this weekend that is a traditional type, so polyethylene with a asphalt backing. And the reality is asphaltic membranes are actually really messy and miserable to work with in the warm weather, which we're into right now. So if anyone's got an asphalt on their hands, had their utility knife plugged up with the asphaltic drool, they're square, if you switch to something like our Mighty Flash, which has an acrylic-based adhesive, you're going to notice a huge difference in cleanliness and keeping your tools clean and your hands not getting covered in asphalt. Secondly, Mighty Flash has stainless steel as part of its makeup. And that extra body, I'm willing to bet, I challenge anybody to use that in hot weather and notice the improvement in workability. Because if you miss an edge or you catch a breeze with a traditional polyethylene membrane, pretty soon you're ending up with a basketball of membrane stuck to itself you're having to throw out. So there's a big workability factor with Mighty Flash, even though the material cost is higher. I think productivity and workability is tremendous when you get into something like that. So just trying to think outside the norm. When you're making a step up to something like Mighty Flash, you'll find the difference is going to be in the application process. So that extra stiffness is a good thing. And getting away from asphaltic membranes, I think, is a good idea. Nobody likes to have to clean black asphalt off their hands at the end of a day, on their clothes, on their fingers, and tools. So I like the idea of switching over to our acrylic membranes.
And the great thing about stainless steel is that it's an inert metal. So you can put it on your wall, and inert basically just means that it's not going to react with anything. So you can put it on your wall with practically any, weather barrier, anything that's going up in your wall, and you don't have to worry about any reactions or compatibility issues with that stainless steel flashing.
Also, if you go to the Mighty Flash link on hb.com right now, you'll notice it's made in the USA and it has a lifetime warranty. So that is also extremely important.
Hey, Linda, do you mind if I shift the conversation really quick to a conversation that Jason and I had the other day?
No, sounds great.
So I was doing some reading, and HB, powered by MyTech, basically on all their flashing, suggests that every time you have a transition of a new flashing, you lap those flashings at a minimum of 3 inches. Now, I was reading on the NCMA that they recommend or suggest, 4 to 6 inches. And Jason, I was wondering if you could just talk about that, because I know you spoke about your infield experience regarding those laps.
Yeah, so we recommend, as far as HMB is concerned, we recommend a minimum of 3 inches. And I think the conversation we had, that 3 inches is minimum. We want to see at least that. So in the field, when you're in a hurry getting your flashing down, you're not going to pre-measure 3 inches. Generally, you're going over that. You know what I mean? You're getting 4 to 5 inches every time, especially when you come up to your corners, because you're going to run it past and then and cut it back to where it needs to be, so it's right out to the length you need it. So I would say more times than not, you're getting well over 3 inches, closer to 5 inches. You know what I mean? Just because it ain't worth the the consultant or the GC coming out as an installer, you know, if you have to peel an 8-foot piece off and you have to do that multiple times down the wall because you put a tape measure on it and it's like 2 3/4 inches or something, it's well worth you just give yourself the extra, and then it gives you some room to tool your bead of sealant on your laps, which is recommended pretty much by any manufacturer out there. Is every lap is tooled with a bead of sealant. The other thing, going right back to the drip edge that we started this with, is best practice is 2 beads of sealant under a drip plate or a rigid metal flashing, and that's just kind of like the word that we commonly use here is belt and suspenders for water infiltration underneath that drip plate, which is something to keep an eye out for in your design, making sure you're getting sealant underneath any rigid flashing that doesn't have an adhesive or sealant built into it. So,
And then going off that drip edge application, how far back are we supposed to apply our flashings from the face of the drip edge? So then it's like kind of under our brick and not flapping in the wind.
I would say generally it's about 3/4 inch back from the face of the veneer.
Okay.
So a lot of that though is for the flashings that have a UV issue, right? They can't, because there are, I mean, you will find that industry resources now tell you can take like a stainless steel and cut it flush, and that's acceptable. What I'll ask you though is that acceptable for how your water is going to get off of your building veneer? Like, what we don't want is that water then coming out of that joint, and industry says, yeah, like it's okay to just leave that flush because the UV is not going to break down a stainless steel, but like you're still going to get that water then to run down the face of your brick. And every time you do that, you risk the opportunity for it to go back in the building with any cracks or hairline openings or any of those. Like, you just don't need to saturate the masonry when not necessary. So we still say we want that drip plate in place.
Right.
And it's just, again, this belt and suspenders approach to saying, how do we best help you keep your building from having moisture penetration in it? And that's one of the ways that we know. We put these flashings at the base of the wall, we put them at the top of the wall, we put them in window openings, over door openings, like any place that you've got the opportunity for moisture to come into your building. We want to make sure that you have this flashing and your end dams and your corners there to direct that water where you want it to go to get it out of your building. So what else, you guys? Is that pretty much our flashing conversation? Did we miss any major topics?
I got one more thing to add. Like we were discussing earlier, it's common industry practice to put the top of your flashings a minimum of 6 inches above any mortar collection device. Now, this was primarily introduced when exterior insulation wasn't being used in our wall cavities, and now with the introduction of exterior insulation, those mortar collection devices and tops of flashings rarely, if ever, meet. But I know that it's still really good industry practice, just to be on the safe side, belt and suspenders, to still suspend those flashings a minimum of 6 inches above your mortar collection device.
Yeah, good point. All right. This concludes our flashings discussion.